Welcome back for calculus. Let's knock out 13 through 16 here. We're in hyperbolas, day 2. We're writing some equations. This time we're given vertices and asymptotes. So what can we do with that? Let's see. From the vertices, we can find the midpoint between the two of them. So that'd be 14 minus 2 divided by 2, 0 plus 0 divided by 2. 14 minus 2 is 12. Divided by 2 would be 6. 0 divided by anything is still 0. So we know that's our center. We also know if our vertices are at 14, 0, and negative 2, 0, and these are vertices, then we're going to be opening horizontally. So we know it is an x first, so x minus 6 squared plus y minus 0 squared. Oh, not plus. Well, that's the only time I did that. Minus, and we're always equal to 1 here. Now, we still need to find A and B. Well, we can find A just fine, right? A is going to be the distance between our center and our vertices. So distance between 6 and 14 is 8. 8 squared is 64. So our A value, though, we said was 8. So if I know A is equal to 8, what do we know this guy here is? Plus or minus, when we looked at writing our asymptotes from yesterday. Remember from yesterday when we were writing our asymptotes, if we have a horizontal hyperbola, which we have here, what went in front of there was plus or minus b over a times x minus h plus k, right? So this piece here, kind of you can think of it as kind of your slope of that line, it's going to be your b over a. So if I know my b over a is 5/4, that's going to be b over my a, which is 8. So now you can say to yourself, if 4 goes to 8, what does 5 go to? That would have to be 10, right? Because they're going to be equal to each other. If that just blew your mind, you can cross multiply like you did maybe in junior high. 8 times 5 is 40. 4 times b is 4b. 5 by 4, and I get 10. So if b is 10, b squared is going to be 100. Not too bad, right? It just has to go back to remember, this is just for horizontal while we're thinking about it. What's the vertical one? Same thing. Everything else is the same. Sorry about my funky K there. Except for it's plus or minus a over b for vertical. All right, let's look at 14. Our co-vertices are 1, negative 1, 5, negative 1. We can still find our center from these two. So 1 plus 5 divided by 2, negative 1 minus 1 divided by 2. 1 plus 5 is 6 divided by 2 is 3. Negative 1 minus 1 is negative 2 divided by 2 is negative 1. All right, these are co-vertices. They are at 1, negative 1, and 5, negative 1. If my co-vertices are horizontal, my vertices are going to be vertical, which means this is going to be a vertical hyperbola. Vertical hyperbolas have the y's going first, so y minus a minus 1 squared minus x minus 3 squared is equal to 1. All right, and since we have a vertical hyperbola, it's going to be a over b is equal to that 1/2 plus or minus, right? Well, we know a. Do we know a? No, we know b this time, right? Because these are co-vertices. The distance between 3 and 5 is 2. So my b value is 2. B squared would be 4. The b value is 2. 2 times what gives you 4? 2. So 1 times 2 would be 2, right? So 2 squared is, oh, be careful, Miss Harris. Messing up here. Let's try that again. A over b is supposed to be equal to 1/2. B is not 4, Miss Harris. What is b? If b squared is 4, what's b, Miss Harris? It says the distance between 3 and 5 is 2. looks a little better. So what does A have to be? It's a little bit more obvious this time. 1. A squared is also 1, so I'll just get rid of this guy here and write it like that. Sorry about that. All right, let's try 15. This time we're given vertices and eccentricity. What do we know E is for all conic sections? C over A. We're going to need that. All right, what's halfway between my two vertices? We find the midpoint, we're going to find the center. So 5 minus 3 divided by 2, negative 2 minus 2 divided by 2. 5 minus 3 is 2, divided by 2 is 1. Negative 2 minus 2 is negative 4, divided by 2 is negative 2. All right, is this horizontal or vertical? My vertices are at 5, negative 2, and then negative 3, negative 2. So my vertices are horizontal, which means we have a horizontal parabola. X is hyperbola. X is going to come first. X minus 1 squared minus y minus a minus 2 is y plus 2 squared. Always equal to 1. If my eccentricity, C over A, is 5 over 4, what else do we know about vertices? Well, the distance between the center and a vertex is going to be my A value. So the distance between 1 and 5 is 4. 4 squared is 16, so that's going to go here. But the distance we said between 1 and 5 is 4. So our A value we say is 4. So what does C have to be for this one? 5. All right, if I know C is 5, then I know C squared is 25. That's also A squared plus B squared, which is what we're actually looking for. When we subtract this 16, we get 9 is equal to B squared, and that guy is going to go down here. I challenge you to try to do the next one by yourself, if you're up for the challenge. If not, here we go. All right, we've got foci and eccentricity. What is halfway between our foci? The center, same thing. So halfway between 0 plus 0, remember this is 2 points. One of them is positive, one of them is negative. Some of you might already see this, but I've got 0 plus 0 over 2, negative 3 plus square root 29, minus 3 minus square root 29. What's that going to equal? Negative 3 minus 3 is negative 6. These guys cancel each other out. Negative 6 divided by 2 is negative 3. So we got 0, negative 3 for our center. Foci, though, are also going to be on our transverse axis. So they're going to tell us whether we're opening vertically or horizontally. Since the change is in my y, in other words, we're at 0, negative 3, plus something, and minus something that are going to be vertical. So we have a vertical hyperbola, which means the y goes first. So y minus 3 squared minus x squared. There's nothing that we're changing the x with there. All right, now, can we find C? You betcha. C is the distance between my center and my foci. So the difference between the difference between negative 3. I didn't even read my own handwriting. This is negative 3, which means this is y minus a minus 3. So the distance between negative 3 and negative 3 plus square root 29 is just square root 29. That's my C value. All right, and we know my eccentricity is C over A. So what does A have to be? A is going to have to be 2. So A squared is going to be 4. That's what's going to go there. That's the easier one. And then we're going to use the C and the A to find our B. So C squared would be negative 29. Square root of 29 squared is equal to A squared, which is 4, plus B squared. This is going to be 29 is equal to 4 plus B squared. Moving that 4 over, I get B squared is 25. All right, that's it for hyperbolas. We've learned everything about conic sections that we really need. The next videos that we'll have after our quiz, which is next Tuesday, are going to be over conic applications. So we're going to be taking these conic sections and applying them to real world problems. You guys have a great weekend.